So let's start the session. Hello, everyone. Good morning, good evening, good afternoon, depending on your location, as we have attendees from all over the world. Welcome to another session of the Data series. We are thrilled to be with you here this evening for a session full of action-packed learning. I, Shishir, along with Jaskirat, part of the data analytics team at Analytics Vidhya, will be the moderator of this session. For those who have joined us for the first time, a brief introduction about the DataHour sessions conducted by the Analytics Vidhya. The data sessions are a series of webinars led by top industry experts which help us to enable deeper discussion and conversation with our cherished community. The data hour is definitely going to be a fun way to understand the concepts of data science from the leading players in the data science domain. We are hopeful that these webinar sessions are going to be a great source of enrichment and value adding for our community members. Now on to our session today, which is about text-based classification using artificial intelligence. In this webinar, you will learn about the different types of AI-based text classification systems along with their advantages, disadvantages, and applications. Now, on to our presenter. In this session of Data Hour, we have with us Riya Nath. Riya is a leader and a mentor in the field of data science and machine learning. She has been working at Oracle for the past 3 years as a data science lead, driving end-to-end development and launch of Oracle Construction Intelligent Cloud Services, which is a new suite of artificial intelligence and analytics application to enable informed project decision in the engineering and construction industry. She has multiple US patents in the field of machine learning and NLP. She has also been the recipient of Analytics India Magazine 40 Under 40 Data Scientist Award. Riya, the virtual stage is all yours.
Thank you so much. So welcome everyone to today's session. Is my presentation visible to everyone?
Yes, it is visible.
Okay, great. So today I will be speaking about text-based classification using artificial intelligence. So here, the first half I will keep for explaining to you what do I mean by text-based classification and using artificial intelligence. And the next half I will go ahead and explain to you a real-life use case that we have worked upon, where we have used text-based classification for identifying health and safety risks in construction industry. So without much ado, I'll proceed further on what do I mean by text-based classification. Feel free to stop me anywhere if you have any questions. We can take those questions at that point. So now what do I mean by text classification? So text classification is a machine learning technique that assigns a set of predefined categories to open-ended text. So any open-ended text, a machine learning algorithm will apply a particular label or category to the open-ended text. And that is what we mean by text classification. So text classification is one of the most fundamental tasks in natural language processing with broad applications such as sentiment analysis, topic labeling, spam detection, intent detection. So these are different kinds of labels that an algorithm provides to open-ended text. So it can be a positive or negative sentiment, different topics associated with the text, or it could be a spam or a ham detection, or any kind of intent detection. So for that, what it essentially does is an input or a text, and any open-ended text is provided to a text classification model, and the model labels the text with a particular category, and then it is shown in the UI as an output with the different categories associated with each and every text. So this is how essentially we are doing the text-based classification. So why do we use artificial intelligence for text classification? Now, as you can understand, manual classification is extremely time consuming and expensive, where manually a person has to go through each and every record of text and understand which category to assign it to or which label to assign the text. So it becomes very expensive in the long run, and it is not scalable also. So that is why artificial intelligence based classification is scalable, it is consistent, and it is faster. So that's why it is more preferred for classification of text. So there are three types of artificial intelligence based text classification system. One is rule-based system, where there are set of rules based on which an algorithm will classify an open-ended text as a particular category or a particular label. The other type of AI-based text classification system is our machine learning-based systems, where you train a classifier on label data set, you build your own classifier, and the classifier will label each and every text record with a particular category. And last one is the hybrid system, which is a combination of both rule-based system as well as machine learning-based systems. Is it clear to everyone? Because I'm not sure the kind of understanding all of you have regarding machine learning, AI. So the prerequisite is you should know a little of what I mean by machine learning or artificial intelligence before we proceed for text-based classification. So is it like clear to most of the people? If some of you can give a thumbs up or something, then that would be great. If all of you are understanding what I'm, okay, so someone has raised a hand, I see. Okay, so I see most people responding as yes, so it is very clear to everyone. So so that's okay, great. So I'll proceed further. So I take it that you already understand what is machine learning and how a classifier separates between different labels. So based on this, I'll proceed with this understanding. So next, what are the popular data sets that you can use for training your classifier? So for topic classification, where the classifier assigns a particular topic to every record or every text record, you can use Reuters news data set, which has one of the most widely used data set for text classification. It has above 20,000 news articles from Reuters labeled with 135 or so categories according to different topics such as politics, economics, sports, business. So these are different topics that are assigned to every article, and you can use this data set to build your own classifier that would assign a particular category or particular topic to each and every news article. So you can also try 20 news groups data set, which is another popular data set, which consists of approximately 20,000 documents across 20 different topics. So you can use these data sets for building classifiers that would identify topics within a particular text, open-ended text body. Okay. Next, you can also use sentiment analysis. You can build classifiers that would do sentiment analysis. So for that, you can use Amazon product reviews dataset, which is also a very well-known dataset that contains approximately 143 million reviews and star ratings ranging from 1 to 5 stars, and datasets spanning from 1996 to 2014. So with this dataset, you can develop your own classifier that would predict the sentiment or the star rating within each product review. So next, you also have the IMDb reviews, which is a smaller data set of 25,000 movie reviews, which are labeled as positive or negative from IMDb or Internet Movie Database. So you can use this data set to build your own sentiment analyzer that would differentiate, that would classify between positive and negative sentiment. So these are all labeled data sets that is available to you, so that you can try building your own classifiers to develop your own classifier that would put every text record in a particular category, or it could be a topic or it could be a particular sentiment. Okay, so I see quite a number of question answers. So there is a question answer raised. So can we get, can we get PPT resource after meet? I would share it with the analytics with their team. I think they should be able to share it with you. Okay. And also, if you have further questions, also please do share it with the analytics with their team. I will take those questions separately also. Okay. Okay, analytics with their team. Do I take the questions now or do I take it separately after the end of the session?
So you can take it separately towards the end. You can proceed with
Okay.
the PPT, the presentation, and towards the end, as the time permits, we can take up the questions.
Okay, sure. Okay, so what are the popular programming languages for natural language processing and machine learning? The most popular language is Python, and libraries like scikit-learn, NLTK, deep learning libraries like Keras, TensorFlow, PyTorch, these are popularly used for building your classifiers for that would classify text for different categories. And also R is used for R. Caret library is very popular. Text2vec is another library. So for Python, Gensim is another library that is popularly used. Some people also use Java. So you can use different machine learning programming languages for building your own classifiers. So you can try out all of this. So the use case that I will speak about next, that would be that we have done both in R and Python. So you can use either of these languages to develop your own classifier. So now I'll speak about one of the use cases where we have used natural language processing and machine learning to identify health and safety risk in construction industry. Now, this has also been published in a paper in Lattice journal, and in their January and March 2022 edition. So you can also connect. I will also share the paper with the analytics India team. I'm sorry, analytics with their team, and you can take a look at the paper if you are interested. So in this paper, I have described the entire use case where we have used text-based classification using artificial intelligence. Okay. So let me introduce you to the problem statement. What is the problem that we are trying to address over here? So the problem is health and safety issues and incidents that occur in construction industry, which very commonly occur in construction industry, and they are a major problem for construction industry projects. Why? Because they lead to budget and cost overruns, and for different projects, construction industry projects, it leads to project delivery schedule delay. It delays the schedule of the entire project, and again, it has an adverse effect on workers, organizations, society, and countries. Wherever there is a health and safety risk issue involved, it leads to adverse effect. So these kind of issues need to be mitigated early on so that they do not lead to major problems. So what we are trying to do here, so we are trying to develop a solution that would identify if there is any health and safety risk issue associated with any open-ended text data. So it can be a correspondences between two stakeholders in the construction industry project, or it can be any exchange of any open text between different participants in the construction project. So in that text, if there is any risk of health and safety issues that might arise in the future, the classifier should be able to detect that early on so that it can be mitigated early on and it doesn't lead to a major health and safety problem in the future. So how did we approach this solution? So we have applied natural language processing based machine learning models to classify text data from textual construction injury reports or any health and safety related construction project reports, as well as any kind of correspondence data between construction project participants. So we have used this kind of data to develop our classifiers. So this health and safety risk system can predict health and safety risk detection subsystem can predict if the text data is associated with any impending risk with high accuracy. So this will enable the project participants to mitigate the risk early on so that further issues do not come up. So the approach that we have followed here is cross-industry standard practices for data management, which essentially involves firstly, business understanding what the problem is very well, and then next understand the data understanding part. What are the data? What is the data that we require to approach to the solution which the business wants, and then prepare the data, explore the data, understand the data very well, so that you can develop a clean solution that would that would help you to achieve this goal for the business requirement. So after preparing the data, you develop the model. The model is then evaluated with different performance metrics. So it's a case-by-case study. So for different classifiers, you need to use different kinds of evaluation metrics. After evaluation, if the model is performing very well on various different unseen data sets, then you can go ahead and deploy the model in production. So that is essentially what we have done. Preparation of labeled text data set for training and testing, data preparation and cleaning. So for NLP, natural language processing, you need to prepare the data, clean the data. I'll come into details regarding that part before you can feed it to any classifier. So after that, after you have the data prepared, you build your model, you evaluate your model, and lastly, you deploy your model. And then you continuously evaluate your model, whether the model is performing well across your different unseen data sets. So the methods that we have used here, the first part is the data preparation, where a labeled data set of over 40,000 health and safety risk related data and 6,000 non-risk related data related to construction industry particularly was prepared. This text data set was prepared, and then each of the records, so each of the records consist of that open-ended text. Now, each of those records, we have cleaned the stop words, removed the stop by removing the stop words. Stop words are very commonly occurring words such as hi, hello there, etc. Any kind of commonly occurring words that are not much useful to understanding the context, those words are removed. Punctuations, numbers, HTML tags, all of those are removed. And all the words are stemmed to their root word with all lowercase character. You can choose uppercase, you can choose lowercase, but they all have to be same case. And also they have to be either lemmatized or stemmed to their root word. So this will reduce the number of features so that you get better features to develop a model that doesn't overfit your training data set. So after that, each correspondence, so each record was vectorized. Now, why do we vectorize? Now, you cannot directly feed text data to any classifier. You have to convert it to a numerical data set, to numbers essentially. So there are multiple ways in which you can convert a text data to a numerical representation. One of the way to do that is using term frequency inverse document frequency matrix. So here, this is a measure of how important a particular term is within a corpus of documents or corpus of text data. So, but the TF-IDF will not take into account the context of your text data. So this is one of the method using TF-IDF. Another method is using document embeddings, which is what we have done. So there are multiple ways on how you can embed your documents or text data, paragraph data, or document data or text data to embeddings or numerical representation using document embeddings. One of the way is what we have done, we have vectorized it to a vector size of 7,000 features using Gensim's doc2vec in Python. You can to a document embedding matrix in which you can see here each row represents a unique correspondence or unique document, unique text data, and each column represents a feature in the vector space. So here you can also use text2vec in R. It will also serve the same purpose. You are converting your text data to numerical representation. So the purpose of this is the text or the text bodies that are very close to each other in the context, they will be closely represented in the vector space, and the text data that are not very close to that are not, contextually not similar to each other, they will be separated from each other in the vector space. So that is how the document embeddings we have developed document embedding metrics for every document. So the methods that we have used, we have after getting the document embedding metrics for each and every document for the 46,000 plus records that I just mentioned to you, we have split the data into training and testing. 90% for training and 10% we have kept for testing, and the classes are are in the same ratio as in the training and testing data set. So they are represented in the same way in both the training and test data set. So after that, we have developed three we have developed three machine learning models based on this training data set, which is a scaled document embedding matrix. Now, you also need to scale all your features so that all your features are in the same scale. And that is very important so that none of the features have a differential impact on your final prediction due to difference in scale. So they should all be, you should bring them all to the same scale. And the scale document embedding matrix was used for building three base classifiers. One is the logistic regression with L1 regularization. So this was important because, as you can see, that I have around 7,000 plus features, 7,000 features in my data set. So it is not possible to manually do feature selection. So L1 regularization will do automatic feature selection because it will shrink the less contributive variables coefficients to 0. So that will do the feature selection by itself. So logistic regression with L1 regularization, gradient boosting algorithm using XGBoost, and lastly, random forest classifiers. So for all these three machine learning models, you do not need to do manual feature selection, and random forest classifiers will only take features that make a which causes a high change in the Gini index or entropy when it selects a particular feature among a subsets of feature for each of its split. Same for gradient boosting algorithm, which is also built on decision trees. So the misclassified points are the probability of misclassified points increases at every iteration, so that the model keeps on improving on the misclassified points, misclassified labels. So that's how, in a nutshell, I just spoke about the three machine learning models that we have worked upon to build the classifier for that would detect a health and safety risk, that would predict whether any text data has health and safety risk associated with it or not. In details is outside the scope of this discussion. What is logistic regression and XGBoost and random forest classifier? If you would like to understand more on this, I'm expecting you already have some understanding of these kind of classifiers, which are basic and commonly used ML techniques. So if you have further questions, we can take it later. So these are the 3 base classifiers that we have built with our document embedding matrix. I hope I'm clear up to now and I'm not going very fast. Can someone tell me if I'm going very fast, or is it okay? Can you, okay, I see a question, why document embedding? Okay, can you repeat trade-off between TF-IDF and Doc2Vec? Yeah, this is a very good question, Kiran. So I just mentioned, right, that TF-IDF will be will not take into account your context, but TF-IDF will performance wise, it will be much better. You can quickly develop your document embedding and develop your classifier, but it will not take into account the context. So the context is very important in this case for both for different kinds of risks, because it's also subjective matter. What might seem as a risk, if you just use a corpus of words, it may not be actually a risk, but you have to take the entire context into picture to understand whether it's actually a risk or not. So let me go to the next slide. I'll take all the questions at the end of this session. So after we build the 3 base classifiers, we have developed an ensemble majority voting classifier, which is an ensemble classifier that is constructed over 3 of the base classifiers that I showed in the previous slide. And all these 3 base classifiers are from different theoretical backgrounds to avoid bias and redundancy. So these 3 base classifiers, based on their majority voting, so each of these classifiers will give a vote, and based on their majority voting, it is the ensemble model that will predict an ensemble of these 3 classifiers that would predict whether a record is, or text record is having a health and safety risk associated with it or not, based on the majority voting of these 3 base classifiers. So the ensemble model predicts a text to be risk if any of the 3 base classifiers classifies the record as a health and safety risk. Now coming to the result, as I mentioned that we had split the data set into train and test, 90% for training and 10% for testing. So what we have done here, this is the first, the training data set is fed to all these 3 classifiers: logistic regression, XGBoost, and random forest. After that, the best ensemble model was selected. Now, each of these individual classifiers, the hyperparameters were tuned based on grid search, so that we find out the model that performs best on your test data set. So that's how these 3 individual classifiers were built, and the majority voting of these 3 classifiers provided us the best ensemble model. Now, separate weightage can be provided to each of these 3 classifiers, and a grid search of the best weights will also give you the best ensemble model. For our case, we found that equal weighting and majority voting gave the best ensemble model. So a grid search for both hyperparameter tuning as well as grid search for best ensemble model weights for each of the votes. So that will essentially give you the best ensemble model. And then the model is selected and based on how it performs on the test data set. So the best ensemble model is evaluated and selected, and it is deployed. And then after it is deployed, the predictions are available to the customer. I'm sorry, there is a power connection, but are you able to hear me? Analytics Vidhya team, are you
Yes,
able?
yes, yes, yes.
Okay.
This
So
word is audible.
I'll just proceed. You can see my screen, right?
Yes, yes.
Okay, fine. So the model is deployed, and then the prediction is available to the customers, and the customers are able to see in the form of notifications, dashboards, warnings, recommendations, aggregations, etc. Whatever health and safety risks are there in past certain period of time, it could be 6 months, 7 days, etc. What are the risks? Which are the records that are having health and safety risk is available to the customer. Now, the customer may or may not agree with what the machine learning model predicts. So the customer is, for our system, the customer is able to tag the incorrect prediction, whichever the customer feels that it is not an health and safety risk, but the model has predicted it vice versa. He can again tag it back to what he thinks as the correct label for that particular record. And this creates a new feedback data for the machine learning model. So a new set of data with label, which has been labeled by the customer, can be created. And this new training data set with the old training, which is appended to the old training data set, and again it is split into train and test, and then this training data set is again used for developing the 3 base classifiers, and with the grid search for the hyperparameters, and also then after that there is a grid search for the weights for each of the votes of the base classifiers to develop the best ensemble model. And then the best ensemble model is evaluated, and then again it is deployed. So this feedback loop continues for every customer until the customer is satisfied with the predictions made by the machine learning model. So with our existing seed model, we observed a very good performance of the model on our test and validation data sets. So these data sets we kept separately, which is unseen for the model. So we see that an accuracy of above 99%, recall precision, ROC under AUC curve was also very these values are also very high, ROC under AUC scores. So so ROC under AUC, this will give you the discriminatory power of the model. So the model is very well able to distinguish between the two classes, the risk and the non-risk. So this gave us confidence that the model is performing well, at least on our validation and test data set. So we deployed the model into production. So this is how we have developed our machine learning text-based classifier for classifying health and safety risks. So in future, we would like to classify different text data based on the intensity of risk. So if there is a high, low, or medium level of risk, the classifier should be able to label that. So how do we develop that? For that also, we would need labeled data set, which is labeled as per the domain experts' understanding of what is high level of risk, medium level of risk, and low level of health and safety risk. For example, some kind of issue which would lead to immediate fire in very near future, that I would consider as a very high level of risk. So that needs to be taken care of immediately. So something that is leading to an environmental issue, that is a high level of risk. So these kind of segregation we should be able to do for different types of health and safety risk, so that high level of risk can be worked upon as soon as possible. Next, we would also like to develop classifiers that would identify other types of risk associated with construction industry. So there is multiple risk associated in construction industry, such as litigation risk, different types of risk. We would like to we have already developed classifiers that would classify different other types of risk in the construction industry, and this will again help the stakeholders in the construction industry to reduce their budget cost overruns or reduce the delay in delivery of the project. So this will definitely help the construction industry as a whole. So this is in a nutshell that what I wanted to speak about regarding text-based classification using artificial intelligence. Now I will go to the questions one by one. So Nikhil, your question is once D1 equal to one single sentence horizon. So D1 means entire document. It can consist of 10 sentence, 5 sentence, whatever it might be. So the entire document is what is your D1 or one document. So based on that entire, so how do we create the label data? We go through that entire document based on the document. Whatever is our understanding, the domain experts understanding, we label the document accordingly, that whether it is a risk or not a risk. Next question, what similarity measure was used? Paulo, yeah, we did not use any similarity over here. We have developed classifiers, machine learning classifiers, to classify between risk and non-risk. It is not a similarity algorithm. So you can use similarity algorithm for other purposes, like if you have a set of documents and you want to find which is the most similar document in your new incoming set of documents, and you can use different types of similarity matrix like Jaccard similarity, cosine similarity based on your use case, and you can assign a similarity score to each of your new incoming documents. So we did not use any similarity measure for our purpose over here. What was it, binary classification or multi-class classification? Rishabh, yeah, your question, it is a binary classification. It is health and safety risk or not a health and safety risk. Further to that, we are in the process of, and we have also developed different categories of risk like high, medium, low. So those are multi-class classification. But the paper that I have explained over here, that is only binary classification. Okay, another question. Can we get, okay, so this I already answered, right? PPT, you can get it from the analytics with their team, hopefully. Next question, it would be good to know why you selected these 3 specific classifiers and not other options. Yeah, so we have tried out different other classifiers also, but for number 1, for majority voting scenario, you would need an odd number of classifiers, and all these 3 classifiers, logistic regression, XGBoost, random forest, these are having completely different theoretical background. So a combination of these 3 classifiers would develop a very strong ensemble classifier. So that is so this is the thinking behind using these 3 classifiers, because they're theoretically different from each other. So they would reduce any redundancy and bias. So if you have same type of classifier, then it would, in your ensemble, then it would increase the redundancy and bias. So you need to have classifiers with different theoretical backgrounds. And also for majority voting, you would need an odd number of classifier. And hence we have selected these 3 classifiers. Mawangi, what text is taken in analysis at beginning? So this is the label data set that we have prepared. So this label data set consists of construction injury reports, construction health and safety risk issues. So those were labeled. It's a risk or it's not a risk. So that's the label data set, which is our training data set to begin with. So every record has been labeled risk or not a risk. So it could be a 1 or 0 binary classification. If it's a risk, we label it 1 or it's a risk, and if it's not a risk, it's a 0. Okay, Surbhi, hi, how to pass part of speech tag while doing lemmatization, and what should be order shall we prefer, doing lemmatization first and then stopword removal, or vice versa? Now it depends on how you approach the problem. You can definitely remove the stop words first, and it depends on how you're removing the stop words. If you are simply using expressions, you then or if you're using a list of stop words that are there in the NLTK library, you can directly remove stop words first, and then after that you can lemmatize it. And how to pass parts of speech tag while doing lemmatization. Now, if you want to remove, uh, say, parts of speech, pronouns, etc., you can remove those, and then you finally do the lemmatization. So it's essential for our purpose. We have done stemming instead of lemmatization, because lemmatization requires a little more performance. It has more I'm sorry, compared to stemming. So we have and in the of different parts of speech, you can go ahead and do the lemmatization. After that, what are the various theoretical backgrounds being spoken here? What business knowledge being conveyed here? Okay, so there are two questions here, Achal. First question is by theoretical background, I mean what is the theory behind these three models: logistic regression, XGBoost, gradient boosting algorithm using XGBoost, and lastly random forest. So if you study the theory, how these models are built, you would know that these are very different from each other. So the entire theory or these models are developed, that is very different from each other. So that is the theoretical background. Random forest, as you know, comprises of decision trees with bootstrap aggregation. XGBoost is again a gradient boosting framework algorithm, which is very is again theoretical background. It doesn't have decision trees. So they are totally different from each other. The detailed theoretical background, I think, is outside the scope of this particular discussion. You can read it anywhere, that three of those are totally different from each other. How they are developed, what is the theory behind these machine learning algorithms? It should be easily available to you. You can go through those. So they're totally different from each other, and hence these three different classifiers were selected to develop the ensemble model. What's the business knowledge being conveyed here? By the business knowledge, I mean to identify what are the main issues that cause problems or that delay projects or that affect the budget and cost of construction projects. So to identify those issues, it is most important here. And one of the issue is health and safety risk, which is a issue in construction industry project. There are other issues like litigation risk, other types of risk associated in construction industry project. So that is the business knowledge that one must have, what the industry is facing currently, and what is the data that is available to us so that we can solve that problem. So that is the business knowledge that is being conveyed here. HP, do the use of hyperparameter tuning on the three classifier model give you issues like time and space complexity when data volume is large? Yes, it does. So if the data volume is large, you would have issues when you do hyperparameter tuning on 3 classifier models. So there are multiple ways. If you are facing such issues, you can reduce your number of features. You can lessen the number of parameters on which you are trying to do the grid search. So if the data volume is large, it does affect the time and space complexity. But how we have handled this? We are providing a seed model, which performance evaluation I already presented to all of you. So this particular the seed model will perform will get retrained on every customer data separately. So each and every different customer will should be able to provide feedback and build their own customer model, customer data trained model. So that way you are not you're only using the data that has been trained by a single customer. So that way you can handle that kind of data, because you do not expect a lot of feedback from a particular customer, and you have so you have different customer models for and customer centric customer uh, feedback train model for every separate customer. So this is how you can handle this kind of issues of time and space complexity. So that's how we are doing it. How much time it took? What do you mean? How much time it takes only to label, build, develop the whole thing? Uh, it takes quite some time. I can assure you that. Specifically, the training data set and then picking which models to use, training them, and also implementing the retraining portion with customer feedbacks, it does take some time. Given the accuracy and performance is so high, would it be convenient to simplify the cleaning of the data, which is very time consuming and expensive, and trade it for some level of inaccuracy, which can be solved later in the feedback loop for clients? Okay. Okay. Now, cleaning the data is not, as per my opinion and what I have observed in my experience, is not that time consuming and expensive. There are multiple methods in very easily you can clean the data. But yes, you have to spend some time to develop those regular expressions and other methods on how to achieve the best performance. So you can achieve best performance with cleaning the data, but previous question that came, the grid search, those and developing new model on customer feedback data, those are more time consuming and expensive. So you should one should always try to achieve the best model where the performance is high, and not compromise on the data preparation part, because data preparation is very critical. Unless you prepare the data very well, you wouldn't get good performance. Even if you get new customer data set, again, if you don't your data preparation methodology is not good, your customer data will not be prepared well as well. So again, your new models would also not perform well. So data preparation is, and after that, all the data preparation step is very critical and most important step. For though we try to reduce it or go over it, but we should ideally we should put effort on preparing the data very well, because ultimately in the long run that would simplify the whole process, and you would keep getting better models when you prepare the data well. Okay. Solve later in the feedback loop. Okay. Upendra, can you show us the data set and code? Unfortunately, the code and data set is proprietary information, so I would not be able to share that with you. But the methodology that I have discussed and in details the paper, if you go through the paper, you should be able to develop your own code from the paper itself. And you can take any data set. I showed a whole lot of data set in the beginning of this presentation. So you can use those kind of data sets, publicly available data sets, and develop your own classifier with the methodology that I've explained in the paper. So sorry, I'll not be able to share the data set with you. Ma'am, where are these models implemented? Okay, Amar Bhota. Hi, Amar. So these models are implemented in Construction Intelligence Cloud, Oracle's Construction Intelligence Cloud based platform, which is a platform that would enable construction industry stakeholders to take early decisions to mitigate risk, as well as handle project delays, etc. So that is a cloud platform that is now in the market. So you can read more on that. Okay, so next question, Pilar. Also, you have seen other uses for text classification like this beside the standard examples of customer satisfaction. Other use cases of text classification I mentioned, sentiment analysis, topic classification. I'm not sure I understand your question well. If you are a little more specific, I can answer that better, I feel. But yeah, so there are multiple uses of text classification. Ratings, Amazon review ratings. So there, as I showed in this presentation, you can use those data set to develop your classifier. Rajan, can you please give an example for multi-class ordinal classification and how the model will be trained? For multi-class ordinal classification, okay, and how the model will be trained. Okay, so for this also you would need a label data set which is having labels of different intensities of risk. Now it is very difficult for people who are not having the domain expertise of which will be a high risk, medium or low levels of risk. It's difficult for them to classify the mails. So you need a domain expert to understand what which of the text would be having high levels of risk, which text bodies are having medium levels of risk, and it is also subjective. Different domain experts might think differently based on their understanding which is high, medium or low level of risk. But once you have the labels of different multi-class labels, then you can directly use those labels and again develop your classifier the same way as I have developed the binary classifier that I showed you. You can develop the multi-class classifier the same way, where you have multiple set of labels. So you would need, of course, training data set with multiple labels for text data. Okay. So next we can go to the next question. How much time in work hours or weeks or months and data science team size did it take to build this model? Okay. I would say it does take months to develop this huge data set. If you need a huge label data set, of course, if you want to build a very robust classifier, it's always better to have more and more and better training data set. It's very important. Your training data set is the most important part of developing your your classifier. So it does take quite some time, and you, of course, you might need a team of people to develop, because there is there is a data ingestion part involved. There is a machine learning, the flow of the data involved, the pipeline, the machine learning pipeline involved. So all this is required So it does take some time to develop, and an entire team has to be, and the you also need to have the UI where you can present the predictions made by the model to the end user. So it does take time to uh, develop the whole platform itself. How did you choose features for vectorization? Okay, so as I mentioned, we did not, because it's a huge number of features, it is not possible to do manual feature selection. And that is why we have selected these three models where automatically the less predictive, the features that do not contribute to prediction would not be selected for in the final model. So if you go through the details, you would get the understanding why these three base classifiers, you do not need to individually do feature selection manually. So that's how we have done. And how did you choose features for vectorization? Okay, features for vectorization is we did using GenSim from doc2vec. You can also use text2vec. So these are pre-trained models for uh, developing your own document embeddings. So these once you use these pre-trained models, you pass your documents and you will, or text, the free text, and you would be able to get an embedding from it. To develop your own embedding, it is a much complex task, and you would need it's a separate set of work where you if you develop your own embeddings, you need your own data set with label data set as well to develop your own document embeddings. For us, we have used GenSim's doc2vec and also text2vec in R, GenSim in Python. So you can use this for vectorization. What are best parameters used to hypertune the model? Now, now parameters are different for different base classifiers that we have used. For example, for XGBoost, learning rate is a good parameter. So you need to do a grid search of different parameters. You need to try multiple parameters and see what is working best on your data set, which is your test data set, which is working best. So based on that, you use there is no hard and fast rule that this is the best parameter and if you tune this, you'll get the best result. It's not like that. You need to try different parameters, and that's why grid search is important, which tries different values of different parameters, and then it finds the best model after the grid search. Arish, you said the number of features it is 7K and not 70K, Arish, number of features. So did you use dimensionality reduction? Okay. So this is a document embedding feature. It is not general ML model features. So this document embedding features we have tested across several different numbers. Like we started with 300, 1000, 2000 and 7000, even more than that. And after all the testing, we found out that 7000 was working best. The accuracy on the test data set was best when we use 7000 features. So for this case, we didn't have to do the dimensionality reduction because you would do dimensionality reduction if your model is overfitting and you want to improve your model also. But for our case, we didn't have to do the dimensionality reduction over here. Did you think about Alejandro? Did you think about using transformers for text classification? Okay. Now, you observe that without using transformer or deep learning, for this particular use case, health and safety risk, because our training data was robust, so the model was very robust itself. You can understand from the performance evaluation of the model. So if you have to use a transformer, you would of course need for every customer, if you want to introduce a feedback loop, as we have done for our case, you would need much more time and space complexity, as mentioned by one of the participants, that would increase multiple folds, right? You would need much more computational resources to be able to handle the retraining of your transformers. And for that, that is the reason we did not use any deep learning technique. And without that only, our basic statistical models perform well. So to develop a clean algorithm, we have just used statistical models for our purpose. Can we get the code? As I mentioned, I'll not be able to share the code with you. But you can go through my paper where in details I mentioned what we have done. How we reconvert the vectorized data to normal data. It's usually not required to convert the vectorized data to normal data, because vectorization is only for the purpose of feeding your text data as a numerical representation to your classifiers. So it is not required to convert the vectorized data to normal data. Again, I'll skip the questions of can we get code, because I have already answered this. What is your approach again? The steps in CRISP DM. Yeah, so you can go through the recording of the this session. You would be able to know that. Can Ensemble apply for clustering? How? Okay. This Ensemble technique you cannot apply for clustering. It is for it is a binary classifier that would classify based on majority voting. So this doesn't apply for clustering. Analytics Vidhya team, I think I have exceeded the time. Should I go through only 2 questions I think are left?
Yeah, you can.
Okay. How does one test hypothesis for NLP model? NLP model using confidence interval. Okay. You can do it the same way as you do any machine learning algorithm. Confidence interval, you can get it the same. For NLP, it is nothing different from any, because you've seen that I've used the same classifiers that can be used for any machine learning problem, the same base classifiers. So you can use the same way confidence intervals for NLP models as well. We are not stacking the 3 base classifier models here, right? Naga's question, we get predictions from each of the 3 base classifiers, and then we are considering the majority voting to decide final prediction is correct. Yes, this is right. We are taking prediction from each of the 3 base classifiers and then considering the majority voting to decide the final prediction. Yeah, so I think I've covered all the questions.
Yes, thank you, Tia, for a wonderful session. I think our audience found it insightful as well. So on behalf of Analytics Vidhya, I would like to thank you for sharing your experience, and hopefully we can conduct such more session with you in future. And it would be great if you can share your contact information so that our audience or attendees can ask questions related to this. So,
sure. You can share my email address.
Okay.
If you have any questions, I'll surely get back to you.
Okay, thank you.